On recording purposes, we are ready to go. First of all, to find this area, we're going to need to draw a graph of these things. One of the things that's going to be important for graphing an x cubed and x squared equation is if we can factor them. The x cubed one you can factor out an x squared, and the other one you can factor out a common factor of x. So both of these graphs, I'm going to do this one in, say, blue. There we go. So that we can see them separately. So for our green graph, we have an x-intercept at 0 and an x-intercept at -2. Because the x squared has a multiplicity of 2, your x cubed graph is going to bounce at that point. And at the other one, the blue graph, you also have an x-intercept at -2 and an x-intercept at 0. And it's a parabola. And it's going to go like this. Now the reason they cross again here at this point is because a parabola increases at a slower rate than a cubic will, so they will cross again. So we know that they cross here and here, that we could see directly. We still have to find that other point where they cross. And for finding the area between these two curves, we're going to have two different sections to do, because in this section the cubic graph is above, but in this section the parabola is above. So let's find out where they intersect. Although we know 2 points already, we can find out the third. X cubed plus 2x squared is equal to x squared plus 2x. Move things over all onto one side, and you get x cubed plus x squared. Nice recovery. Minus 2x equals 0. We can factor out an x, leaving you with x squared plus x minus 2. X plus 2, x minus 1. So we get x equals 0, which we knew, and x equals minus 2, which we knew. But now we know the other one happens at x equals 1. And obviously, you can see by my scale already, it was perfectly drawn to scale. So we've got our points. Now we can do the integral. Now the integral will happen in two different parts. I'm going to call this part A and this part B, just so that you can follow along easily. For part A, it'll be the integral. Do these have names? We're going to give them new names just to make things easier. I should have had some gray out, but I only have white out. I'm going to call this f of x and this one g of x, so that when I show the integral, we can go from -2 to 0, and we called the cubic f. So the green one was f, and the blue one was a g. So the first one is going to be f minus g dx. And then you're going to have to add to that the integral from 0 to 1. And now it's going to be g minus f. Okay? Because one time the cubic is above and the other time the parabola is above. So what does this mean for our equation? From 0 to 2, that's our section A, and from 0 to 1, that's our section B. Yes, Ichi? If you don't change the order but put an absolute value, it will work. Yes.
Is that points taken off for that?
What's that? Would you take points off for? No, but you still have to do it separately.
Because if I go negative value, I would want to do all the work to make sense.
That's right. Just go back and put all the absolute value.
But it has to be inside, right? Like null outside the...
Well, if you did this f minus g here, and you got a negative number, then you put absolute value on the outside all the way through, and that would be fine. Now I'm trying to think of a shortcut, but we'll do it this way first, and then we'll see if we can come up with a theoretical way to make this shorter. No, I don't know if I can figure out a way. Okay, so here we go from f minus g. If I take the x cubed one and minus, if I take the x cubed one and minus the other one, this will be the integral from -2 to 0 of x cubed plus x squared minus 2x dx. And the next one, if I took the parabola and subtracted the cubic, I'll get negative x cubed minus x squared plus 2x dx. Are you okay with that? At this point, it's going to get a little bit messy, so I'm going to just create some space by erasing this. The integral of the first one will be x to the 4 over 4 plus x cubed over 3 minus x squared from -2 to 0. And then you're going to add, and here the integral will be negative x to 4 over 4 minus x cubed over 3 plus x squared from 0 to 1.
We don't put the c's because...
We don't have to put plus c because when you subtract them, they would all cancel out. So anytime that you're doing a definite integral, you can just put it in the square brackets like this and not worry about the constant. So this one will be plug in the -2 and minus what happens when you plug in the 0. I'm going to do that in mental math first. And then there's going to be plus, and then you're going to plug in the number, and then you're going to minus. Oh, right, yeah, that one. You're going to plug in the 0 first, right? You plug in the bigger number first. Here, like 0. There we go. We'll figure that out afterwards.
Can you do -2 and 0 in the bottom?
Can you do -2 and then 0 on the bottom? Well, you always go from the bigger value, subtract the smaller value. So that might have been another place where your numbers might have gone off a little bit. So the bigger one here is going to be the 1, and then we're going to minus the 0. So now let's put in our other values. This is going to be 16 over 4 minus 8 over 3 minus 4. And over here, you're going to get -1 over 4 minus 1 over 3 plus 1. Again, this part here and this part here, this is section A and this is section B. Just to go back to our graph before so we can visualize what's happening. Now, if we've done everything right, when I simplify section A, I should get a positive number. And this is going to be 4, right? This part's going to be 4 minus 4 will be 0. Negative 8/3, yes. I get 8/3 for section A. And for section B, this will be -3/12, -4/12, -7/12, plus 12/12 will be 5/12. And 8/3 plus 5/12 will be 37/12. So this is how we can get our graph to do it with a non-calculator. It wasn't actually that bad without the calculator, just had to do the different sections, and we get 37/12. Now we're going to look at how we can use our calculator to figure this out, and I'll show you some tricks on the calculator as well. All right. So I've graphed the x cubed plus 2x squared and the x squared plus 2x. If we take a quick leak at that graph, a quick look at that graph, there it is. Now, unfortunately, there's not a good thing to see the area between. There's not something where you can do the integral where it shades in between that I know of. So I might get a post from somebody who's studied this lots on the graphing calculator and tell me, oh, there is a good way, but I highly doubt that. So what we're going to do is we're going to go back here and we're going to say sometimes we did the parabola, and what I'm going to do here is I'm going to put the function f, I'm going to put this one was in y1, right? And the blue one was in y2. So here, at first, I have y1 minus y2. That's my section A. And my section B was y2 minus y1. So there's a way on your graphing calculator for you to type that in without having to type it in separately each time. So in equation 3, if you hit the vars button and then go over to the y variables and go over to function, they list them, y1, y2, y3. So the first one I want to do y1 minus, I'll do that again, vars, go over to y variables, go over to function, y1 minus y2, I'll put that into my y3 as a third equation, and into y4 I'll do the opposite. I'll do y2 minus vars, y vars, function, y1. Now, if I wanted to find section A, it was y1 minus y2. So I have a whole bunch of graphs going on right now. What I can do is I can keep them all there by pushing enter on the equal sign. I can turn them off. And now when I graph it, I just get section A, which was y1 minus y2. And if I go second, calculate number 7 from -2 to 0, I get 2.6666. And if I check what is that number, because that will always be saved, can change it to a fraction. And that's my 8/3 for section A. Oh yeah? Look at that. We'll figure that out for next class. Okay. And then to find the other one, we'll turn on y2 minus y1. There's the graph. Second trace. Number 7. Have a good night. We'll go from 0 to 1. And change that answer to a fraction. And you get the 5/12. So it all works. Have a good night. And that's the end.